tangga ke angkasa.
Assalamualaikum dan selamat sejahtera kembali kita dalam sesi Akademi Revision. Anda tak tahu mana nak mula? Jom kita mula dari sini. Okey, jadi subtopik pada hari ini masih daripada subtopik chapter 2 iaitu subtopic 2.3 under projectile motion. Okay, we will learn about projectile motion in 3 types of motion. The first one, when the object is launched at an angle. Okay, ada sudut. Okay, contoh. Okay, let's say we have the object here and the object is moving at angle of theta. Alright, so it's moving upward and reach the maximum height here and then moving downward. Okay, you can see here, okay, we have Vx and Vy. Okay, look at the value of Vx. Okay, at any point, the value of Vx is always equal to Ux. It's constant. Dia tidak berubah. Okay, in x direction. But how about Vy? Look at Vy. Okay, initially the value of Vy, let's say, at this point, the value of Vy is positive 30 meter per second. And at this point, masa yang diambil to travel from the release point to here is 3 seconds and Vy is 13 meter per second. Okay, look at here, when this object reach the maximum point. Okay, alright. So this is the maximum point. At t is equal to 6 seconds, you can see here the maximum point. Okay, here is at t is equal to 6 seconds, the object reached the maximum point. And remember, at maximum point, at maximum height, the Vy, okay, is equal to 0 meter per second. And then, what happened to the object? The object will move downward. Okay, kita akan tengok nilai Vy ni akan mula menjadi negatif because the direction of the motion sekarang ke arah bawah. Okay, moving downward. Okay, here, 0 meter per second, negative 10, negative 20. Okay? Okay, so now you can look at to the parabolic path. Okay, this is the direction of the initial velocity where the object is launched at an angle of theta. Ada angle. Okay, so kita akan tengok seterusnya. Okay, second is when the object is launched at zero angle. Apa maksud zero angle? Nama lain dia adalah projected horizontally. When the object initially projected horizontally, the direction of u is horizontal. Okay? So tak ada angle. So no need to resolve the u. Now, if the question give you the value of u here, where here is the value of ux. Ux is equal to 20 meter per second. And how about uy? Uy is equal to 0. Tak ada uy. Okay? Sebab dia adalah projected horizontally. So now you can see, as usual, okay, ux is equal to vx at any point of the motion here. Until it reach the ground, vx still equal to ux. And how about vy? In this motion, vy is always negative sign. Okay, negative value because the direction is downward. Okay, so now when the object reach the ground, you can see here, Vx is to the right and Vy is downward. And the direction of V, okay, V is equal to, kita boleh kira V, where V is equal to Vy squared plus Vx squared and take the square root. Okay, saya pasti awak semua dah hafal formula tu. Okay, look at here. Okay, kita ulang. The motion of the ball. Okay. Alright. Okay, next. Okay, the third one, when the object is launched at 90 degree. Okay, means that kita baling bola tu ke atas, straight line, 90 degree, atau kita baling bola tu ke bawah. Tengok, kita baling bola tu ke bawah, so 90 degree. Or we call it as free fall motion. Okay. Ataupun kita baling bola tu ke atas. Okay, look at here. When we throw the ball upward, alright, Okay, the ball is moving upward. Alright, so this is the release point. So when the ball is throwing upward, so this is positive SY. Dia bergerak ke atas, positive SY. Okay, how if the ball is moving downward? When the ball is moving downward, so this is negative SY. Alright, when the ball is moving upward, so it's positive SY. Okay, so now the ball reached the maximum height. So bila dia patah balik, come back to its release point. Okay, look at here. Mula daripada sini naik atas, positive SY, and then plus negative SY. So what is the displacement, the total displacement of the ball? Positive SY plus negative SY. So it's equal to 0. Remember. Okay. Alright. So this is another example. Okay, you can see here. For the first case, we have the object that launched at angle of theta. Okay, for example, we fired a bomb, for example, at angle of 30 degree. Okay, so let's start. So it's moving in this direction and moving downward. Okay, look at here. Okay, the green color is the velocity vector. So this is Vx and this is Vy. Okay. Okay. So look at here. So we have here is Vy. The direction of, this is U. Launch initial velocity. Let's say Uy is upward and this is Ux. Okay, the yellow arrow here means that it's the direction of the acceleration, and the direction of the acceleration is always downward, selalu ke bawah, sentiasa ke bawah. Okay, so okay here, at any point the direction of acceleration is always downward. Okay, kita tengok lagi sekali, kita ulang lagi sekali. The direction of the acceleration is always downward. Okay. So now look at the maximum height. What happened at maximum height? Okay, I think this is the maximum height. Okay, you can see here at maximum height, no direction of Vy, because Vy at maximum height is always equal to 0. And this is Vx. And the yellow color here, okay, the yellow arrow here is the acceleration, the direction of the acceleration, where the acceleration of the object, okay, is under gravitational acceleration. Okay. Alright, so this is the diagram, another diagram you can see here. Okay, so now you can look at here. Ini yang gambar tadi lah yang you tengok pada awal tadi. So it's moving upward and then moving downward. You can look at to the arrow change. Okay, start from here. Okay. Allah. Sorry. Start from here. Okay, can see here U. When we resolve U, Uy is upward and Ux is to the right. Okay, and look at here. So when projected at angle of theta, we need to resolve our initial velocity U into X and Y component. Okay, and at this point, okay, remember, it's at maximum height. Okay, belum lagi. Alright, at this point. You can see here, at maximum height, Vy is equal to 0. Here, Vy is also equal to 0. And you can see, when the object is moving upward, the direction of Vy is upward. But when the object is moving downward, the direction of Vy is downward, negative direction. Okay, and how to find V here? V is equal to square root Vx squared plus Vy squared. Okay, so this is the equation. Okay, how to resolve U? Okay, so now how to resolve U? Okay, at angle of theta here, so Ux is equal to U cos theta, and Uy here is U sin theta. Okay, good. Alright, so now look at the motion. Okay, the motion is accelerated. Okay, betul, motion is accelerated. under the gravitational acceleration, but the acceleration is constant and downward. Dia ada acceleration negative 9.81 meter per second squared, but it's constant all the way. Okay? And the horizontal component x, okay, the horizontal component of velocity, Vx, is constant. Vx dekat mana-mana, kat sini, dekat sini, dekat sini, mesti sama. Okay? The horizontal and vertical motions are independent of each other. Okay, contoh, kenapa tidak, apa maksud dia independent of each other? Means that at this point, okay, Vx ada nilai dia, Vy pun ada nilai dia. Okay, dan kita kena kira asing lah. What is Sy? What is Sy from the ground to here? What is Sy? And what is Sx from here, from the launching point to here? What is Sx? Okay, but they have a common time, t. Tapi masa yang diambil, masa tak ada x ataupun y. Tak ada kita kata tx, ty, tak ada. Masa tetap sama lah. Okay, bila dia bergerak, what is the time taken to reach here? So, itu masa dia ada satu saja masa. No direction. Okay. Tapi, Sx boleh kira, which is the horizontal displacement Sx and vertical displacement Sy. This one. Okay. Horizontal Sx, Sy, Vx, Vy. Okay. So, they are independent of each other. Okay. But for t, okay, they have the common t.
Okay, let's discuss the first question. An object is fired from the ground at 100 meters per second at an angle of 30 degrees with the horizontal. Means that's given that, let's say we have an object here, okay, where the object is launched or fired, okay, at 100 meters per second. That means the initial velocity of the object is 100 meters per second. Alright, and given that the angle is equal to 30 degree. Okay, 30 degrees with the horizontal. So the first question asks us to find what is the horizontal and vertical components of the initial velocity. And before we start to answer this question, alright, when we look at to this diagram, we can straightly resolve the initial velocity into x and y components. Alright, so let's try to resolve. Okay, so this is the direction of u, okay, where u is equal to 100 meter per second. Okay, and let's say we have the horizontal line and the angle here is 30 degree. Alright, so now we want to resolve u into x and y component. Okay, so we have ux is to the right. Okay, so ux, and then we're gonna have uy. Okay, so you have uy. Alright, so we can label here is ux, where ux is equal to, alright, look at to the angle, where the angle here, okay, is near to x component. Okay, so siapa yang dekat is cos. So we use cos, so u cos theta. Okay, the direction of ux is to the right, so it's u cos theta positive value. So u is 100 cos 30 degree. Okay, so we can calculate, so it's 86.6. Okay, and how about uy? So uy is upward, so uy is equal to u sine theta, which is u sine 30, 100 sine 30. Okay, 100 sine 30 degree, sorry, so this should be equal to 50. Okay, so let's look at the question number 1. So we want to find the horizontal velocity, which is ux. Okay, so remember, at any point ux is always constant. So ux is equal to, so ux is equal to 86.6 meter per second. Okay, that's all. Okay, next, so uy, so we have calculated there, uy is also equal to 50 meter per second. Okay, so that's the answer. Alright, so now proceed to question B. So question B asks us to find how far has the object traveled in the horizontal direction, okay, after 2 seconds. Okay, so as we know, we want to find the horizontal displacement. How far? Okay, how far means that, okay, means that from this one, from the launching point to here, for example. Let's say at 2 seconds, the object is here. So we want to find what is Sx. Okay, so let's say, given that, okay, we just predict, let's say at this point, let's say at t is equal to 2 seconds. So the object is here, means that we want to find the horizontal direction. Okay, so we want to find the horizontal displacement. How far the object travel in the horizontal direction. So we want to find here Sx. Okay, so we want to find what is Sx. Okay, so this one should be how far. How far. Okay, how far. Okay, so now, okay, remember the equation. Okay, the equation is equal to Sx is equal to uxt. Okay, so we can use this equation straightly. We can substitute the value where ux is equal to 86.6 and t is at 2 seconds. Okay, and the answer should be 173.2. 173.2 meter. Okay, means that at 2 seconds here, okay, the horizontal displacement from the launching point is 173.2 meter. Okay, so now let's proceed to question C. How high is the object at this point? So we want to determine what is Sy at t is equal to 2 seconds. Okay, so remember, so this is the Sy. Okay, so we have Sx. So now I want to draw Sy. Okay, the vertical displacement Sy. So we want to determine what is Sy. Okay, so now we can straightly substitute the value. So Sy, write the equation first. Sy is equal to uyt minus half gt squared. Okay, where this is the equation. Okay, so now uy is equal to 50 and t is 2 seconds, half 9.81, t is 2 seconds. Okay, we can calculate the answer is equal to 80.38 meter. Means that at t is equal to 2 seconds, okay, the height of the object is equal to, here, Sy is equal to 80.38 meter. So let's move to question number 2. Okay, question number 2. Let's read the question. So a projectile is launched from a cliff 100 meters above level ground. So given that the height of the cliff is 100 meter above the ground. Okay, and so here we have a projection here where, okay, which launch at 30 meter per second at angle of 20 degree. Alright, so means that we have u here. Okay, so where u is equal to 30 meter per second and its launch. So let's say this is the path. Okay, at angle of 30 degree, sorry, at angle of 20 degree to the horizontal. So means that this is the angle 20 degree. Alright, so now the first step, you must resolve the initial velocity. So where u, so in this direction, so we have u, okay, and we're going to have ux, okay, so ux, and we're going to have uy, okay, and that's like this one. Let's try to move. Okay, all right, so now let's write the information. So we have u is 30 meter per second, and this is 20 degree, and I want to write ux here, where ux is u cos 20, and it's 30 cos 20, okay, and the value is 28.19 meter per second, and this is uy, which is 30 sine 20, and it's equal to 10.26. All right, so now let's back to the first question. Okay, A, we want to find what is the range, where range is the horizontal displacement upon impact. So this is the position, okay, where the impact happen. Okay, objek tu jatuh di sini, okay, from here, and now, so from here to here, okay, so this is sx. Okay, so now let's try to calculate sx. As we know, the equation of sx is equal to uxt, okay, where t is the time taken from the starting point, daripada sini tadi turun sampai ke bawah. Kan kita nak cari sx ini, kita mesti tahu what is the time taken, okay, the flight time, okay, berapa, okay, here, okay, we call it as time of flight. Okay, so now if you look at here, okay, so actually this is the horizontal part. Kalau you nampak yang ada xx, so itu adalah horizontal. So I want to put this as horizontal, and this part is for the vertical calculation. Okay, let's try to highlight vertical and horizontal. Alright, so now move for the vertical. So now I'm trying to use sy as equal to uyt minus half gt squared. Okay, kenapa saya guna yang ini? Sebab tengok sini ya, kita ada maklumat 100 meter. Okay, so at this point, okay, so the object is moving upward. So this is the maximum height, and come back to here. Okay, so we consider here is 100 meter. Okay, so dia akan jadi macam ni lah. Okay, kita launchkan kat sini tadi. So let's say here is tadi 100 meter. Okay, so kita launchkan tadi 100 meter here. Okay, so now let's say this is the sy. Okay, tengok ini adalah maximum height h yang kita tak tahu. So objek tu tadi daripada sini pergi ke atas, okay, positive h, and come back to this point. So here is negative h, so positive h plus negative h, so 0, and then move downward, which is 100, negative 100 meter. Okay, so here is negative 100 meter. Okay, so the total, okay, so the total displacement, okay, kita assume dia daripada sini lah. Okay, from the on the top of the cliff, 100 meters above level ground. Okay, so kita ambil ini adalah 100 meter, so launch kat sini tadi. Okay, so remember, positive h plus negative h, and selebihnya adalah ketinggian dia tadi kat mana kita launch. Daripada tempat kita launch, from the launching point to the ground, so it's negative 100. Kenapa dia negative? Okay, because the direction is downward. The direction of motion is downward. So, mesti letak negative. So, now it's equal to negative 100 is equal to uy 10.26 t minus half 9.81 t squared. Alright, so from here, I can find what is the value of t. Since the value of t here, okay, sebab kita consider the whole journey tadi, so t yang kita kira ini adalah, okay, time of flight ataupun the total time taken to travel from starting point to the ending point. So this is the time of flight. So let's try to calculate t, and you will get the value of t is equal to, so the value of t, okay, is equal to negative 3.59 second or 5.68 second. Okay, so kita ambil yang positif lah. So negatif ni tak nak. So ini adalah dia punya t. Okay, alright, so now we can substitute the value of t to here, because we want to find sx, okay, the range ataupun the maximum horizontal displacement sx here. Okay, so sx is equal to uxt, where ux is equal to 28.19 and t here is 5.68. So the answer is 160.1. So now part B, okay, we want to calculate the peak height from the ground, okay, which is h plus 100. Okay, you can see here, okay, we have h here, okay, and this is 100. So we want to calculate h first. So B, so we want to calculate the time taken to travel from starting point to the maximum height h. Okay, you can see here, okay, so we have from here, okay, launch u, okay, so we want to calculate what is the maximum height here, okay, h, from here to here. Okay, so this is sy. So we need to know what is the time taken. Daripada sini tadi kita launch, okay, sampai naik atas ni berapa time taken dia. Okay, so kita tak tahu kan berapa dia punya maximum height. Okay, and at this point, at maximum height, yang kita tahu, okay, the velocity vy at maximum point, okay, is equal to 0 meter per second. So kita gunakan maklumat ni, therefore vy is equal to uy minus gt. Okay, where t here, okay, ini, so kita guna vy ni kita gantikan dengan kosong. Okay, so gt ni, ini mestilah time to reach maximum height. Okay, masa yang diambil daripada sini sampai sini. Sebab tu kita kena guna vy dekat sini adalah 0. Okay, saya masukkan dekat sini. So now we substitute uy. So we can just straightly substitute 10.26. Okay, 9.81 t. Therefore, we can calculate t is equal to, okay, 1.05. Okay, ini masa yang diambil untuk sampai ke maximum height. So now we can calculate lah dalam masa 1.05 second tu, what is its sy. Okay, kalau kita nak kira ni, so guna y lah, vertical components. Okay, okay, therefore sy is equal to uyt minus half gt squared. Okay, where uy is equal to 10.26, t is 1.05 minus half 9.81 t squared tadi 1.05 squared. Okay, so substitute the values. Okay, so the answer will be equal to 5.4 meter. Okay, so ini adalah daripada mana? 5.4 meter tu daripada sinilah, daripada launching point tadi. Okay, sini sampai ke atas. So ini adalah 5.4 meter. So maximum height from the ground should be equal to H should be equal to SY plus ketinggian cliff tadilah 100 meter. Okay, so 105.4. Okay, so the maximum height from the ground. Okay, and next, okay, we want to calculate so C, we want to calculate what is the velocity at 2 seconds after launch. Okay, so you want to calculate what is the velocity at 2 seconds. Okay, T is equal to 2 seconds, where Ux is equal to, okay, and Y is 10.26. Okay, so we want to calculate, so Ux at any point, okay, Ux is always constant, okay, constant at any point. Okay, tak kisahlah at T2 equal to 2 seconds, 4 seconds, okay, so dia mesti constant. Okay, so Ux is constant at any point, therefore at T is equal to 2 seconds, Vx is equal to 28.19 meter per second. Okay, and Vy is equal to Uy minus Gt. So Uy is 10.26, 9.81, and T is 2 seconds. So now Vy is equal to, so 9.81 times 2, 9.36 meter per second. So therefore at 2 second, okay, tengok sini ada direction ni. So at 2 second, Vy is downward because negative, and Vx is positive. So the direction of V, maknanya dia dah turun ke bawah lah at 2 second. Okay, direction of V is downward. So now in order to calculate V, therefore V is equal to square root Vx squared plus Vy squared. Okay, kita masukkan nilai. So Vx kita berapa tu? 28.19 squared plus Vy is 10.26. So what is the angle here? So theta, okay, direction is equal to inverse tangent Vy over Vx. So Vy is negative 9.36. Okay, so angle dia akan dapat berapa? Okay, so let's continue with question number 3. Okay, so a tennis player hits a ball horizontally. So horizontally means that U here is equal to Ux. Okay, where the height of 1.6 meter above the horizontal ground. So here is 1.6 meter. the ball lands 10 meter away. Okay, so here we have ux. Okay, kita tak tahu berapa nilai dia. Okay, and as we know that when projected horizontally, okay, we just have the value of ux and uy is equal to 0. Automatically, uy is equal to 0. So, kita hanya ada value ux, tak ada uy bila projected horizontally. Okay, and the ball lands 10 meter away. So, given that here, okay, from here to here, okay, is from here to here is 10 meter. Okay, 10 meter. So, apa yang diberi oleh soalan, what is given by the question, alright, so I want to divide into horizontal component and vertical component. Okay, so we have horizontal and vertical. So now, the information given by the question, the first one is, we know that uy is equal to 0. So, we put dekat bahagian y. Kita letak dekat bahagian y. Okay. And now, when the object is moving from here, it's projected in this direction and moving downward at this point, the object is traveling downward direction. Means that we have sy is equal to negative 1.6 meter. Okay. And how about sx? Okay, so sx here, we know that daripada sini, okay, daripada sini ke sini, we know that it's 10 meter. Soalan bagi, it's equal to 10 meter. Okay, positive 10 meter. Alright, so now we want to calculate what was the speed of the ball as it left the racket. Okay, so we want to find what is u. U tadi ux lah because projected horizontally. So we want to find u, okay. Okay, so we have sx. Let's say I want to use equation of sx is equal to uxt. Okay, we do have the value of sx here and we want to find ux, tapi kita tak ada time. So what is the time taken to travel? Okay, so now I will use the information from the vertical components in order to find the time. Okay, so kita pun tuliskan formula. Okay, so I have sy. So sy is equal to uyt minus half gt squared. Okay, kalau katanya, boleh tak cikgu kalau saya nak guna yang ini? Vy squared is equal to uy squared minus 2gsy. Okay, tak boleh lah sebab kita tak ada time. Kita nak guna time. Okay, cannot. Okay. Ataupun you nak guna Vy is equal to Uy minus Gt. Tak boleh sebab kita tak ada nilai Vy. Okay, we don't know what is the Vy here. So, V, kita tak tahu. Vx tak tahu. Vx is equal to Ux. Sorry, Vy is equal to tak tahu. Okay, so tak boleh juga guna yang ini. Okay, so we strictly use Sy is equal to Uyt minus half Gt squared. So, we can just substitute the value. Okay, so Sy is negative. So, make sure you substitute the negative. Negative 1.6. Okay. So, negative because the direction of motion is downward direction. Dia bergerak ke bawah. So, Sy dia mesti negative. So, Uy is equal to 0. So, cancel. Tak adalah bahagian sini Uy. Okay. So, negative half 9.81 T squared. Okay. So, finally, kita akan dapat T is equal to 0.57 second. Okay. Now, we can use the horizontal components here. Okay, we can use this equation Sx equal to Uxt in order to solve for Ux. Ux tu U lah. Okay. Therefore, Ux is equal to Sx over T, where Sx is given 10 meter and T is 0.57. Okay, so Ux kita akan dapat 17.54. meter per second. Unit jangan lupa. Okay. So we are finished. Question number 3.
Okay. Okay, for the second part, launch at 0 angle means that the object is horizontally launched. Okay. And you can see here, no angle. So the object is projected horizontally at angle of 0. Okay. So you can see the green color here is for UX. Okay, we can start. Okay. So we just have UX. At this point, baru kita ada direction of VX and VY. Okay, masa permulaan ini, initial velocity U is to the right. So U is equal to UX. Okay, UY kosong. Automatically UY kosong. Bila you baca soalan, you nampak projected horizontally, UY mesti equal to 0. Okay. Okay, remember, ini yang saya cakap tadi, UY is always equal to 0 meter per second. Okay, when projected horizontally, the value of initial velocity U that given in the question is the value of UX. Okay, UY kosong.
Okay, so now let's proceed to question number 4. Okay, we have a tiger leaps horizontally. Okay, so word horizontally means that the tiger is moving in horizontal direction. Okay, dia melompat ke depan, horizontal direction. From a 7.5 height rock with a speed of 4.5 meter per second. How far from the base of the rock will she land? Okay, means that the direction, okay, so projected horizontally means that in this direction. So U is equal to UX, so is equal to 4.5 meter per second, where UY is equal to 0. Okay, bila projected horizontally. Okay, so now, let's say, okay, so this is the landing point. So we have the landing point here. So now we want to calculate what is how far from the base. So ini base dia tadi. Okay, how far from the base of the rock will she land? Oh, sorry. Okay, so kita nak kira ni berapa. Okay, so kita labelkan dia sebagai SX. Okay, so kita nak cari what is SX. So as usual, so I will write this as horizontal and this is vertical. Saya akan asingkan. Okay, so alright, so now horizontal we have UX, which is 4.5 meter per second, and for the vertical we have UY, which is 0 meter per second, and then the tiger is, the direction of motion for the tiger is downward direction. So SY, so daripada sini tadi dia lompat ke atas, turun bawah, and when the tiger reach this point, maknanya SY dia, ini ketinggian inilah, ketinggian batu tu 7.5 meter. But make sure you put negative 7.5 meter. Okay, why negative? Because negative is the direction. Okay, the direction of motion is downward. Okay, so now we want to find SX. What is SX? Okay, so SX is equal to UXT. Okay, sama macam tadi, kita tak ada nilai T. Okay, kalau kita nak cari SX, dia buat kita ada UX, kita tak ada T. Tadi soalan sebelum ni, okay, soalan sebelum ni kita ada SX, tapi kita tak ada UX. So sama kan? Cara soalan bertanya saja yang berbeza. Okay, so now mana kita nak dapat? Okay, so sekarang kita tengok sini, we want to find SX. We have UX, but we don't have the value of time T. So dari mana kita nak dapat? So look at the vertical component. Okay, so from the vertical component, we can find what is T by using equation SY equal to UYT minus half GT squared. So I can cancel this one. Since UY is equal to 0, then SY is negative 7.5 half so negative half 9.81 t squared. Therefore, t will equal to, okay, cuba awak semua kira. What is the value of t? So it should be 1.2 second. Okay, then we can substitute t in order to find Sx. So Sx, so Ux is 4.5 and t is 1.2 second. Okay, so 4.5 times 1.2, so it's equal to 5.4 meter. Dapatlah jawapan kita. Okay, so finish question number 4. Okay, now question number 5. A bird is flying horizontally, so ada perkataan horizontally, with a constant speed of 2.7 meter per second when it releases a rock from its beak. Okay, so the motion of the bird, so let's say we have a bird here. Okay, sorry for my drawing, I know it's terrible. Okay, so it's moving with constant speed and flying horizontally, so the direction is here and u is given 2.7 meter per second. So when it releases a rock from its beak. Okay, so let's say this is the rock and it's from the bird's beak, and you also masih sama lah dengan burung tadi, mereka bergerak sama-sama kan. So the bird release the rock. Okay, so let's say the motion is like this one. So it's moving downward. Okay, and here is the ground, for example, and here is SY. So here is SY. Okay, so we don't know what is SY and we also don't know what is SX, but the question gave you the time the rock lands on the ground 2.1 second later. Okay, the time for the rock lands on the ground is, okay, the flight time is equal to 2.1 second. Okay, so given that t is 2.1 second and u here we have ux is equal to 2.7 meter per second and uy is equal to 0. Okay, so these all the informations that we have from the question. So now we have the horizontal and vertical components. Okay, so we have uy here, which is uy is 0 meter per second and ux is 2.7. Okay, so time tak ada direction lah kan, scalar quantity, so keduanya time yang sama. Okay, so now we want to calculate the rock's horizontal velocity. So we want to calculate ux. Perlu ke kira ux? No, sebab dia dah bagilah. Okay, dia dah bagi dah speed dia. Okay, so berapa? So in order to answer, so A is straightly u is equal to 2.7. Okay, B, the rock's vertical velocity. So we want to find what is the velocity of the rock, okay, when it touch the ground. Okay, berapa? So as we know, at this point we're gonna have V, and here is Vx, where Vx is always equal to Ux, and we want to find what is Vy. Okay, so yang A ni tadi, dia tanya just before the rock lands, what is the rock's horizontal velocity? So ini adalah V lah. Okay, Vx. So now we want to find Vy. So we want to find Vy is equal to 0 minus 9.81, 2.1 second. Okay, 2.1 second. Vy is equal to 20.6 negative. Okay, so negative 20.6. So negative because the direction of Vy is downward direction. Okay, so Vy here because the direction is downward direction. Okay, okay, so awak tengok kat sini lah, nampak Vy ke bawah, Vx ke kanan lah. Therefore Vy is equal to
So Vy is equal to, okay, so just before the rock lands, what is the rock's vertical velocity? So the answer is negative 20.6 meter per second. Okay, so C. How would your answers in part A and B change if the speed of the bird would increase? Kalau lah speed of this bird increase, what happened to the Vx and Vy? Okay, what happened to Vx and Vy? Remember, Vx is always equal to Ux. Okay, therefore, when Ux is increasing, then the value of Vx, which is the horizontal velocity before the rock lands on the ground, is also increased. Okay. And how about Vy? So Vy is equal to Uy minus Gt, 0. You can see here, okay, you can see here that Vy does not depends on, okay, does not depends on Ux. So kalau bird ini tadi bergerak, dia increasekan dia punya speed, okay. So what happened to the Vy? So you can see here Vy is equal to negative Gt. Vy does not depends on Ux. Therefore, Vy, okay, does not change. Okay, ataupun constant lah, tidak berubah. Okay, so the answer is here. Okay, so finish question number 5. Y kosong. Alright, now the last part is when the object is launched at 90 degree. Okay, so the angle here you can see it's 90 degree. Means that the object is moving upward, throwing upward or downward. Okay, so okay here. So let's say the object is moving upward and downward. Okay. So for this case, the object is moving upward. Dia bergerak ke atas with initial velocity of u. Dia ada u dia. Okay. Tapi kalau you release the ball downward, means that u is equal to 0. You release the ball from rest. Okay. So, object in motion solely under the influence of gravity. Yes, betul. Okay. Nama lain dia, we call it as free fall motion. When the object launched at 90 degree, we call it as free fall motion. Does not involve x component. Okay, kita hanya ada uy, vy, sy. Okay, tak ada sx, tak ada ux, tak ada vx. Okay, use equation for y component only. So, uy, when the ball is thrown upward, okay, when the object is thrown upward, the initial velocity uy must be positive. When the ball is thrown downward, so the uy is negative value. Okay, but if the question state that the ball or the object is released, drop, okay, from the top of the building, for example, uy must be 0 meter per second. Okay, you can see here, let's say we have the release point here, and the object will move upward. So uy is equal to positive value. Okay, where here, the displacement traveled by the object here, and the object is moving upward, so sy is positive value. Okay, and how about when the object is moving downward with the initial velocity u? So the value should be negative because the direction is downward. Okay, so it's moving downward and sy must be negative value because the direction is downward. So the displacement is negative. Okay, so look at here. So it's moving upward. So let's say this is one of the example. So the ball is moving upward. I call it the first displacement traveled by the ball is sy1, where sy1 is equal to positive 2 meter. Moving upward, positive 2 meter. Okay, so now the object back to its release point. Come back to its release point. It's moving downward. So sy2 is equal to negative 2 meter. Negative because the direction is downward. And what is the total displacement traveled by the ball? Okay, macam biasa, SY1 plus SY2. SY1 is positive 2 plus negative 2. And the total displacement traveled by the ball is 0 meter. Okay, SY is displacement. Okay, not the distance. Kalau the distance traveled by the ball, yes, it's 4 meter. Gerak ke atas 4 tambah 4 because we not consider. Okay, we not consider the direction. We ignore the direction. Okay, but the total displacement SY should be 0 meter. Okay, good. Okay, so let's proceed to question number 6. So we have a ball is thrown upward from a balcony with a speed of 3 meter per second. Means that the initial speed is 3 meter per second. 8 meter above the ground. Alright, so let's say this is you. Okay, and the ball is thrown upward. So this is the ball. Oh, sorry. Okay, so it's 8 meter above the ground. Okay, so this is the release point. Okay, so where this is 8 meter above the ground. Okay, we consider it's 8 meter above the ground. So we want to calculate what is the time taken for the ball to hit the ground and the speed at which it hits the ground. So dia tanya speed bukan velocity. Okay, so speed you must give the magnitude only, not the direction. Alright, so now when we look at to the path of the ball when it's thrown upward, so let's say it's moving upward and then move downward. Okay, here we can calculate. So now here we have u. Okay, where u is given as 3 meter per second. It's positive 3 meter per second because it's thrown upward. But v, since v is moving downward, so v, the velocity should be negative value. Okay, because the direction is downward. Alright, so now let's say we have a point and we call this point as the maximum height. Okay, means that the ball is thrown upward and reach the maximum height and moving downward and then touch the ground. Okay, so now as we know, at maximum height, the Vy is equal to 0. Remember, in the projectile motion, when theta, in this case, theta is equal to 90 degree, and we also call this as free fall motion. Okay, so 90 degree, so ada y saja, no x. Alright, so now, so we have uy is equal to, okay, so uy is equal to 3 meter per second and vy here is equal to 0 meter per second. Okay, this one is at maximum height. Okay, so what is the time taken for the ball to hit the ground and the speed at which it hits the ground? Okay, so bola itu bergerak dengan initial velocity, dia berapa tadi? 3, and then it's come back here. Okay, as we know, the motion of the ball, tengok kat sini ya, kita tak tahu berapa ketinggian sini daripada release point sampai maximum height. Okay, let's say I put it as h. Okay, saya letak dia sebagai h sahaja. Saya tak tahu berapa. So now the ball is travelling upward. So daripada here, from here, release point. So bergerak ke atas sampai maximum point, it's positive h. Alright, positive h. And then it's moving downward and plus, okay, negative h. So we want to calculate the total displacement. Okay, positive h plus negative h. And then the ball is moving downward. Where, as we know, this height is 8 meter. Okay, saya ulang. So this is positive h plus negative h plus negative 8 meter. Alright, so now we can write another information for the SY total. Total displacement traveled by the ball for the whole journey, daripada mula sampai ke ground, so it should be positive h plus negative h plus negative 8. So it should be, tak muat dekat sini. So it should be negative 8 meter. Negative 8 meter. So now we can solve. What is the time taken for the whole journey? Here, from here to here, what is the time taken? So let's write. The equation that we want to use here is equal to Sy is equal to Uyt minus half gt squared. This is for the whole journey. Okay. Kenapa saya highlightkan for the whole journey? Sebab SY yang kita nak masukkan ni tadi SY total. And T yang kita nak kira ini adalah time taken for the whole journey. Okay, now let's substitute. Sy is equal to negative 8. Uy is 3T minus half 9.81 T squared. Okay. So we can solve the problem, okay, where it's equal to 4.90 squared minus 3t. So this is the quadratic equation. Minus 8 is equal to 0. Okay, so now you can use your calculator and you will get the time t is equal to 1.62 second, and another t is negative 1.007 second. Alright, so negative value, okay, you cancel the negative value. Therefore, the answer of t, the time taken for the ball to hit the ground, t is equal to 1.62 second. Okay, so this is for question A. Okay, now we want to find the speed at which it hits the ground. That's mean the final speed. Okay, so Vy is equal to Uy minus Gt. Okay, so let's substitute. U is equal to 3 minus 9.81 and T for the whole journey from here to here before touch the ground is 1.62 second. Okay, so the answer is negative 12.876. So negative 12.88 meter per second. Therefore, the question asks you the speed of the motion is downward. So this is downward direction. Okay, therefore the speed V is equal to 12.88 meter per second. Okay, you also can use another equation. Okay, so let's say you want to use another equation. Okay, let's say you want to use another equation. You can still use Vy squared. Okay, let's say you want to use another equation. Vy squared is equal to Uy squared minus 2G Sy. So now, okay, this is the second method. Okay, so as we know Vy, we want to find Vy. Uy is 3 squared minus 2, 9.81 Sy. So we have calculated Sy just now for the whole journey. It's equal to negative 8 meter. Alright, so now let's proceed. Substitute negative 8. Okay, so negative 8. So okay, therefore, the value of Vy squared is equal to 165.8. Okay, but we want to find V. So V is equal to square root plus minus 165.8, and the answer should be plus minus 12.88. 12.88, okay, meter per second. And this is the velocity, the direction is downward, so we would choose negative answer for this one. But therefore, we want to find the speed. Speed, you can just mention the magnitude only. Okay, baca soalan betul-betul. Okay, 12.88 meter per second. Alright. So let's proceed to question B. Alright. So what is the maximum height of the ball from the ground? So as we know, at maximum height, Vy is equal to 0. Okay, and given that tadi, Uy is equal to 3 meter per second. Okay, therefore, we can find what is Sy. At maximum height means that I want to find from here to here only. Okay, so H, I want to find H. Okay, so I want to use equation of Vy squared equal to Uy squared minus 2G Sy, where this Sy, I put it as Sy maximum. Okay, okay, maknanya saya tahulah daripada H ini. Okay, Sy ini adalah H. Okay, kejap lagi kita akan gantikanlah supaya kita nampak dalam kita punya diagram, dalam kita punya lukisan, it's H. Okay, so now Vy, so Uy is 3 squared minus 2, 9.81, and Vy is 0. Because at maximum height, Vy is 0. Okay, so now Sy is H. I put it as H because this value yang kita kira is only from the release point to the maximum height. Kita tak tambahkan lagi dengan daripada from the ground. Kita kena tambah dengan 8 meter lah kalau kita kira the maximum height. So yang kita kira tadi hanya H. Okay, so the value of H is equal to 0.46 meter. Okay, so the maximum height, okay, should be equal to H plus 8 meter, which is equal to 8.46 meter. Okay, so kalau maximum height, kita mesti kira daripada tanah ni lah ketinggiannya maximum height. Okay, boleh. Alright. Okay, sebab soalan pun dah mention, calculate the maximum height of the ball from the ground. Okay, so the answer is 8.46. Okay, now question number 7. An object is dropped from the top of a building. Time to hit the ground is given 3.85 seconds. Okay, means that we have an object where, let's say this is the object and this is the release point. Okay, from the top of the building. So let's draw the release point first. Okay, let's say we have the object here. Okay, and the object is released from the top of the building. What is the height of the building? So it's moving downward. Okay, so it's released from the top of the building. So means that here Uy is equal to 0. Okay, and we want to find what is the height of the building, where H here. Okay, so we have Uy, we have T. Okay, we can find Sy. Okay, Sy is the displacement traveled by the object from here and moving downward. So that Sy should be negative because the motion is downward motion. Okay, so Sy is equal to Uyt minus half Gt squared. Sy kita nak cari, so Uy is equal to 0, so negative half 9.81, T is 3.85 squared. Okay, and when you substitute all the values, you will have your Sy, where Sy is the total displacement traveled by the object. Daripada atas, turun bawah. That means Sy itu adalah dia punya H, the height of the building. Okay, so the answer is equal to negative 74. Therefore, the height of the building, okay, is equal to 74 meter. Okay, so negative sign means that it's direction. Okay, displacement. So we have magnitude and direction. So negative 74, and we want to answer the height of the building. So it's 74 meter. So now we finish discuss all the questions, and I hope you can understand all the problems that we have solved just now. Okay, jumpa lagi. Para pelajar yang belum like, subscribe dan sharekan channel saya kepada kawan-kawan anda. Boleh like, boleh share dan boleh subscribe. Semoga kita bertemu lagi dalam next subtopic. Okay, so bye. Terima kasih dan selamat sejahtera. Assalamualaikum.